Your Ford Maverick has factory-programmed settings that are quietly destroying its powertrain from the inside out, and the manufacturer is betting you won't notice until the warranty expires. So you say. Most owners have no idea that the very features highlighted in the glossy sales brochures as modern engineering breakthroughs are actually designed to satisfy government regulatory credits at the direct expense of your truck's longevity. You are driving a vehicle that is actively sabotaging its own mechanical components every single day you turn the key. Today, I am exposing 5 factory settings and features that are causing hidden damage, severe wear, and long-term financial waste without you ever knowing it. Setting number 3 has caused the most catastrophic premature engine failures I have witnessed inside the service bay. And setting number 1 is so deceptive that most owners actually think it is beneficial to their wallet when it is doing the exact opposite. Let's get into it. Setting number 5, the factory 10,000-mile Intelligent Oil Life Monitor calibration. Every Maverick rolls off the assembly line with an Intelligent Oil Life Monitor calibrated to let you drive up to 10,000 miles or a full year before triggering an oil change alert. Ford markets this as a high-tech, cost-saving feature that protects the environment and reduces your maintenance overhead. They want you to believe a computer algorithm is precisely measuring the chemical integrity of your lubricant. But here's what Ford doesn't tell you. That algorithm is a mathematical model based on idealized lab conditions, and it completely ignores the harsh reality of modern engine physics. Whether you drive the 2.0-liter EcoBoost or the 2.5-liter hybrid, letting your oil run for 10,000 miles is actively cooking your engine bearings and starving your internal components for protection. In the EcoBoost variant, the culprit is severe fuel dilution caused by direct injection. The high-pressure fuel injectors spray gasoline directly into the combustion chamber at pressures exceeding 2,000 pounds per square inch. Under light loads and short trips, a measurable percentage of that raw gasoline escapes past the piston rings and washes directly into the oil pan. I have pulled oil samples from Mavericks at the 6,000-mile mark, where the oil smelled like pure, regular unleaded. This fuel dilution acts as a solvent, aggressively thinning out the factory-recommend 5W30 oil until its viscosity shears down to the equivalent of a 0W16 or worse. If you own the hybrid, the mechanism of destruction shifts to moisture accumulation and acid buildup. The hybrid powertrain is designed to constantly cycle the gas engine on and off. If your daily commute consists of short trips under 15 minutes, the engine never achieves its optimal operating temperature of 212 Fahrenheit. Without hitting that thermal threshold, the water vapor created during combustion cannot evaporate out of the crankcase. Instead, it condenses into the oil, mixing with sulfur and nitrogen oxides to form trace amounts of nitric acid. By the time your digital dashboard finally tells you that you have 10% oil life remaining, the fluid inside your engine has lost its hydrodynamic shear strength. The micro-thin barrier of oil that is supposed to keep the steel crankshaft from touching the soft Babbitt metal of your rod bearings completely collapses. The consequence is invisible, cumulative metal-on-metal wear. Every mile driven past the 5,000-mile threshold on factory oil is eroding your engine's internal clearances, leading to premature timing chain stretch, oil consumption, and eventually, catastrophic bearing failure that will cost you thousands of dollars out of pocket. The solution is incredibly simple. Ignore the digital monitor completely. Do not wait for the truck to tell you when it needs service. Manually change your oil and filter every 5,000 miles or every 6 months, whichever comes first. If you subject your truck to heavy city traffic or short trip driving, drop that interval to 4,000 miles. Spending an extra $50 a year on an early oil change completely neutralizes the single biggest engine killer built into the factory programming. Setting number 4. The factory auto start-stop default configuration. Setting number 4 is a feature that Ford integrates into the EcoBoost Maverick to squeak out a fractional increase in the EPA city fuel economy ratings. It is the factory auto start-stop setting, which is programmed to kill your engine the exact microsecond your truck comes to a complete halt at a stoplight, only to refire it the moment your foot leaves the brake pedal. Ford builds this as an eco-friendly advancement that prevents unnecessary idling. But under real-world conditions, this constant cycling is creating the exact mechanical environment that destroys your crankshaft journals and your turbocharger shaft bearings. To understand why this is happening, you have to look at how an engine maintains lubrication. When your engine is running at normal idle speed, the mechanical oil pump maintains a constant pressure that suspends the rotating crankshaft inside the engine block. This is called hydrodynamic lubrication. The metal parts literally float on a pressurized film of oil without ever touching each other. The moment the auto start-stop system shuts the engine down at a traffic light, that oil pressure immediately drops to zero. The oil begins to drain away from the upper galleries and back down into the oil pan. When the light turns green and the system rapidly restarts the engine, there is a critical delay of roughly 500 milliseconds before the oil pump can repressurize the oil passages. During that half-second window, your engine is operating under boundary lubrication conditions. The heavy metal crankshaft grinds directly against the dry bearing surfaces. While Ford utilizes specialized, coated bearings to withstand this, no coating can completely eliminate the frictional heat and wear generated by restarting your engine 20 or 30 times during a single afternoon commute. Over a standard 5-year ownership window, this feature subjects your engine to hundreds of thousands of additional dry start cycles that it would never experience otherwise. The damage is even more severe for the turbocharger. The turbo spins at rotational speeds exceeding 100,000 revolutions per minute and operates at temperatures that can easily surpass 1,000 Fahrenheit. The turbo relies entirely on a continuous flow of engine oil to cool its center cartridge and lubricate its journal bearings. When you pull off a high-speed highway and immediately stop at a red light, the auto start-stop system shuts the engine off while the turbo is still white-hot. With the engine dead, the oil flow stops entirely. The stagnant oil sitting inside the turbocharger bearing housing instantly bakes, a destructive process known as oil coking. The oil turns into hard carbon crust, which acts like sandpaper the next time the turbo spins up. This scores the precision shaft, destroys the oil seals, and leads to a smoking, failing turbocharger that requires an expensive replacement. The solution requires you to change your starting habit every time you get behind the wheel. The moment you push the ignition button to start your truck, immediately look down at the center console and press the Auto Start-Stop Disable button. Make it an involuntary reflex, just like putting on your seatbelt. By turning this feature off every single time you drive, you preserve your engine's oil pressure when it matters most. Protect your turbo from extreme heat soak and prevent thousands of unnecessary friction cycles on your internal bearings. We've already bypassed the manufacturer's deceptive oil change intervals and shut down the bearing-killing auto start-stop system. But the hidden mechanical threats built into your Maverick run much deeper than basic engine components. The next two settings target the very components that make your truck drivable: its advanced thermal management and its electronic braking systems. And they are failing quietly right under your feet. Today, we are diving straight into the top half of our countdown, exposing the factory configurations that dealerships pray you never question until you are standing out of warranty at the service desk. Let's get into it. Setting number 3. The EcoBoost Passive Cooling Fan Strategy and LTR Calibration. Setting number 3 is the factory thermal management programming on the 2.0-liter EcoBoost engine, specifically the passive cooling fan strategy and the low-temperature radiator (LR) calibration. Ford programs the electric cooling fans to remain completely dormant until the engine coolant temperature climbs to a staggering 218 Fahrenheit. And even then, they only spin at a low efficiency percentage unless the air conditioning head pressures demand more airflow. Ford markets this as a strategy to optimize fuel efficiency by reducing the aerodynamic drag and electrical load of running the fans, while allowing the engine to heat up rapidly to reduce internal friction. But here's what the factory service manuals leave out. This high-heat operational strategy is actively cooking your cylinder head gaskets and accelerating the thermal degradation of every rubber seal and plastic quick connect fitting under your hood. The mechanism of destruction relies on localized thermal spiking that the dashboard temperature gauge completely hides from you. The factory temperature gauge on your instrument cluster is not a real-time thermometer. It is a heavily dampened dummy gauge programmed to stay perfectly centered anywhere between 180 Fahrenheit and 230 Fahrenheit, so owners do not panic. When you pull a steep grade or drive through heavy stop-and-go traffic on a hot afternoon, the cylinder head temperatures spike rapidly. Because the EcoBoost utilizes an aluminum cylinder head bolted to an aluminum block with an ultra-thin multi-layer steel head gasket. These massive thermal swings create mechanical stress known as differential thermal expansion. The aluminum head expands and contracts at a slightly different rate than the block casting, scrubbing against the head gasket material. By keeping the fan trigger threshold so high, Ford forces the engine to live on the absolute edge of thermal safety. Over time, this constant heat cycling degrades the clamping force of the factory cylinder head bolts. The head gasket begins to develop micro-passageways, allowing combustion gases to leak into the cooling jackets and pressurized coolant to seep into the combustion chambers. Furthermore, this high-temperature calibration destroys the auxiliary cooling circuit responsible for lowering the temperatures of your transmission fluid and the liquid-to-air intercooler. When the cooling fans remain off during low-speed driving, the transmission fluid temperatures regularly climb past 220 Fahrenheit. At this temperature, the automatic transmission fluid begins to oxidize, losing its anti-shudder properties and breaking down the clutch friction materials, leading to erratic shifting and premature transmission valve body failure. The consequence is a slow, invisible decline into catastrophic cooling system failure. You will not see a puddle of fluid on your driveway at first. Instead, the engine will quietly consume its own coolant, creating misfires on cold starts, white exhaust smoke, and eventually an overheated engine that warps the cylinder head beyond repair, leaving you with a $5,000 replacement bill. The solution requires a manual adjustment of how you operate the vehicle's climate control system to force the factory computer to override its internal thermal programming. Whenever you are driving in heavy city traffic, climbing long hills, or operating the truck in ambient temperatures exceeding 85 Fahrenheit, you must turn on the maximum air conditioning setting or ensure the AC compressor is actively engaged. Engaging the air conditioning system forces the powertrain control module to instantly command the electric cooling fans onto their high-speed setting, regardless of the actual engine coolant temperature. This continuous high-velocity airflow pulls the excess thermal energy out of both the primary radiator and the secondary cooling loops, dropping your operational temperatures by as much as 20 degrees and keeping your cylinder head well away from the thermal deformation zone. Setting number 2. The factory electronic brake booster and regenerative grinding calibration setting number 2 is an integrated software configuration found heavily inside the Maverick Hybrid, but also affecting the electronic brake assist modules across the platform. The factory electronic brake booster calibration and its aggressive transition phase between regenerative braking and mechanical friction braking. Ford markets this electronic brake setup as a seamless, high-tech solution designed to harvest maximum kinetic energy to recharge the high-voltage hybrid battery while maintaining premium stopping power, but inside the wheel wells. This factory calibration is creating a highly destructive environment that causes severe rotor warping, premature pad crystallization, and uneven electronic caliper dragging. To understand the hidden mechanism, you have to look at how the truck actually stops. Unlike a traditional vehicle, where your foot physically presses hydraulic fluid directly to the calipers, the Maverick utilizes a brake-by-wire system. The pedal is merely a digital sensor that tells a computer how fast you want to slow down. The computer then decides how much deceleration to pull from the electric motor spinning backward, and how much to pull from the actual brake pads clamping the iron rotors. The engineering flaw lies in the transition logic programmed into the brake module. To maximize fuel economy ratings, the software holds off on applying the mechanical brakes as long as possible, using the electric motor to do the heavy lifting. But the exact moment the vehicle drops below 7 miles per hour, or the moment the anti-lock brake sensors detect even a microfraction of tire slip on an uneven road surface. The computer suddenly drops the regenerative braking completely and slams the mechanical brake pads against the rotors with tremendous electronic pressure, because this application is controlled by a high-pressure electric motor inside the booster rather than the progressive feel of your human foot. The pads hit the iron rotors with a sudden, violent spike in clamping force. This instant torque transfer creates localized flash heating on the surface of the brake rotors. The metal faces of the rotors experience thermal shock, rising hundreds of degrees in a fraction of a second. This extreme localized heat changes the molecular structure of the cast iron, converting patches of it into a hard, brittle material called cementite. Once these hard spots form, the rotor no longer wears evenly. The brake pads begin to bounce over the cementite formations, creating a violent steering wheel vibration every time you slow down from highway speeds. Additionally, because the computer handles the rear brake biasing electronically to prevent the truck from veering forward under sudden deceleration, it quietly commands the rear brake calipers to maintain a slight, continuous pressure against the rear rotors, even when you are just cruising down the street. This micro-dragging is completely imperceptible to the driver, but it creates constant friction, glazing the brake pad surfaces until they become smooth as glass, losing their stopping efficiency and causing the rear brakes to squeal like a garbage truck. The consequence is a brake system that destroys itself long before its time. You will find yourself facing severely warped rotors, pulsing pedals, and ruined brake pads at less than 20,000 miles, and the dealership will routinely deny warranty coverage, claiming that worn brakes are a standard wear and tear item caused by your personal driving habits. The solution to this electronic braking trap is a deliberate alteration of your braking technique to rewrite how the factory computer calculates deceleration. You must avoid making sudden, late braking inputs that force the computer into its high-pressure emergency transition mode. Instead, practice long, steady, and light brake pedal applications well ahead of where you need to stop. By keeping the digital pedal input light and consistent, you allow the electric motor to handle the entirety of the deceleration phase smoothly, preventing the electronic booster from violently spiking the hydraulic pressure at the last second. Furthermore, once every week, you should perform a hard, deliberate stop from 40 miles per hour in a safe, clear area with the vehicle shifted into neutral. Shifting the transmission into neutral completely disables the regenerative braking system entirely, forcing the mechanical brake pads to scrub hard against the rotors. This intentional friction cleans off the glazed resin layer from the pads, removes surface corrosion, and ensures the calipers self-adjust properly, preventing the uneven wear patterns caused by the factory software. We have exposed the oil monitor algorithms, deactivated the starter-killing start-stop programming, forced the cooling fans out of their dangerous dormancy, and corrected the flawed electronic braking logic. But everything we have uncovered so far pale in comparison to the #1 feature built into this truck. The final item on our countdown is the most deceptive, widespread, and mechanically devastating factory setting of them all, and it is something you likely rely on every single day, thinking it is keeping your vehicle running smoothly. Today, we are stripping back the final layer of manufacturer misdirection to look at the single most destructive configuration Ford engineered into the modern Maverick platform. Let's get into it. Setting number 1. The factory transmission fluid fill for life and 150,000 mile service. Schedule the absolute #1 most harmful and deceptive factory configuration on the Ford Maverick is the official maintenance schedule designating the transmission fluid as a fill-for-life component, requiring its first scheduled inspection or fluid exchange at a ridiculous 150,000 miles. Whether you are driving the 8-speed automatic bolted to the EcoBoost or the electronic, continuously variable transmission paired with the hybrid, Ford's official service manual explicitly tells owners that the fluid inside these gearboxes is engineered to last the lifetime of the vehicle under normal conditions. Dealership sales departments use this to pitch the truck as a low-maintenance miracle that saves you hundreds of dollars in shop visits during your first decade of ownership. But here is the hard mechanical reality that I see on the lift every single week. Treating transmission fluid as a lifetime component is a mathematical death sentence for your gearbox. Designed strictly to lower the manufacturer's calculated cost of ownership metrics during the initial warranty period, while ensuring a catastrophic mechanical failure immediately after it expires. The hidden mechanism of destruction is rooted in the severe thermal and mechanical shearing that happens during the first few thousand miles of the truck's life. In the 8-speed automatic transmission, the fluid is not just a lubricant. It is a hydraulic fluid tasked with transferring immense pressure through microscopic passages in the valve body to engage multiple clutch packs during the factory break-in period. The brand new steel gears and friction plates undergo a process called micromachining, shedding thousands of microscopic metallic particles, aluminum shavings, and clutch material fibers directly into the fluid. The factory magnet inside the transmission pan can only hold on to a fraction of this debris. The remaining suspended metallic silt acts as a polishing compound, circulating through the high-pressure solenoid valves, eroding the precision aluminum bores, and scoring the critical sealing rings simultaneously. The intense heat generated by the transmission's internal friction causes the factory fluid to suffer from mechanical shear. The long-chain polymer additives that give the fluid its specified viscosity are literally ripped apart by the crushing force of the planetary gear sets. By the time the truck hits just 30,000 miles, the fluid has degraded from its original specification into a thin, oxidized liquid that can no longer maintain the necessary hydraulic pressure or thermal barrier in the hybrid's electronic transmission. The destruction follows a different but equally lethal path. This gearbox houses two high-output electric motor generators completely submerged in the transmission fluid. As these electric motors cycle rapidly between propulsion and heavy regenerative braking, they generate massive fields of electromagnetic energy and immense localized heat spikes that exceed 300 Fahrenheit on the motor windings. This extreme thermal load causes the transmission fluid to break down via thermal oxidation. The fluid begins to thin out and lose its dielectric properties, meaning its ability to act as an electrical insulator decreases. As the fluid degrades and accumulates microscopic metallic wear particles from the transfer gears, it becomes slightly conductive. This allows microcurrents of electricity to arc through the fluid, creating a process called electrical pitting on the precision needle bearings and gear teeth. The surface metal is microscopic exploded away, creating tiny craters that rapidly accelerate into a loud, whining bearing failure that completely locks up the transaxle. The consequence of trusting Ford's 150,000-mile timeline is a total, unmitigated transmission failure that almost always occurs between the 70,000 and 100,000-mile mark, conveniently just past the expiration of the factory powertrain warranty. When the valve body bores erode or the hybrid motor bearings pit, the truck will begin slipping gears, shuddering under acceleration, or dropping into a digital limp mode. Because these modern gearboxes are highly integrated and incredibly complex, dealerships do not rebuild them. They simply quote you $7,000 to $9,000 for a complete unit replacement, completely wiping out every cent you ever saved on fuel. The solution requires you to completely reject the concept of lifetime fluid and establish a strict, proactive, preventative maintenance schedule. For the 8-speed automatic EcoBoost Maverick, you must perform a complete transmission fluid drain and fill every 30,000 miles. Do not allow a shop to perform a high-pressure machine flush, which can force dislodged debris deeper into the sensitive valve body solenoids. A simple gravity drain and refill replaces the worn-out additive package and removes the suspended metallic silt safely if you own the Maverick Hybrid. The fluid change interval can be extended slightly, but it must be performed no later than every 45,000 miles to neutralize the thermal oxidation and conductivity risks to the electric motors. Taking control of this single maintenance item completely rewrites the longevity timeline of your truck. converting a transmission engineered to fail at 80,000 miles into a bulletproof powertrain capable of clearing 200,000 miles without a single hitch. Conclusion: when you look closely at how the modern Maverick is configured from the factory, a very clear pattern emerges. The extended oil change intervals, the aggressive start-stop programming, the high-heat cooling strategies, the abrupt electronic braking transitions, and the deceptive lifetime transmission fluid ratings are not engineered to make your truck last forever. They are calculated compromises designed to satisfy federal regulatory mandates and corporate marketing spreadsheets, leaving you to foot the massive repair bills once the factory warranty drops off. Protecting your investment does not require complex mechanical engineering degrees or thousands of dollars in aftermarket modifications. It requires a fundamental shift in how you maintain the vehicle and a refusal to follow the generic, corporate-dictated guidelines found in the glove box. By taking matters into your own hands, changing your oil at 5,000 miles, disabling the auto start-stop on every ignition cycle, managing your thermal load with the climate control overrides, smoothing out your braking inputs, and performing fresh transmission fluid drains every 30,000 to 45,000 miles, you actively reclaim control over your truck's mechanical destiny. You strip away the built-in obsolescence and ensure that your vehicle delivers the true, long-term financial value it is capable of providing. If this deep dive gave you the actionable insight you need to beat the manufacturer at their own game and save thousands in future repair bills, make sure to hit that subscribe button right now. Drop a comment below letting me know your current mileage and which engine configuration you are running. And let's make sure your Maverick stays out of the service bays and on the road where it belongs. Keep your oil fresh, stay ahead of the hidden math, and I will see you on the next vehicle breakdown.